Hello, everyone, and welcome back. And today we're going to be talking about the origins of modern astronomy. Just as a table of contents, we're going to be going over this week in astronomy and the history of astronomy. Right, so this week in astronomy, we're going to start off with the James Webb Space Telescope. And the James Webb Space Telescope recently took a really nice image of the pillars of creation. As always, these images are in infrared, and so they can see more young stars that would be forming in this large galaxy. And here are just a couple of photos. Next, it saw this fingerprint in space. That was pretty cool. Look at that. Those are actually the gravitational waves of the stars moving the dust that they emit around them into spherical patterns, which we see as waves. So that's pretty cool. All right, now for the big boy for the Hubble Space Telescope. So I took a photo of this galactic triplet called ARP. As we can see, we have one galaxy over here, another galaxy over here, and one over there. Next is the NGC 1999 nebula. This one's pretty cool. Next we have these two stars. Pretty cool, pretty cool. Tarzan star cluster. Very nice. All right, so starting off with the history of astronomy. Let's start off by talking about early astronomy. Earth is one of the 9 planets and many smaller bodies that orbit the Sun. There are billions of galaxies in the universe, and the Sun is a much smaller part of just one galaxy. And a few hundred years ago, scientists thought the Earth was at the center of the universe. So ancient Greeks believed that astronomy is the science that studies the universe, and astronomy deals with the properties of objects in space and the laws under which the universe operates. So the golden age of early astronomy was centered in Greece and happened from around 600 BC to 150 AD. The early Greeks used philosophical arguments to explain natural events, but they relied mostly on observations. The Greeks used instruments such as the astrolabes to track the motions of the stars and the sun. The Greeks also developed the basics of geometry and trigonometry, which were incredibly helpful to make astronomical calculations back then. And using these branches of mathematics, they measured the sizes and distances of the sun and the moon. The Greeks made many astronomical discoveries. One of the most famous Greek philosophers, Aristotle, concluded that the Earth is round because it always casts a curved shadow when it passes between the sun and the moon. And Aristotle's belief that the Earth is round was largely abandoned in the Middle Ages. Even though Aristotle's other theory about geocentrism was incredibly popular at the time. So the first successful attempt to establish the size of the Earth is credited to a Greek mathematician known as Eratosthenes, and he observed the angles of the noonday sun in 2 Egyptian cities that were roughly north and south of each other, which were Syene and Alexandria, and he used that to calculate basically how much distance was between them, and then extrapolated that to account for the entire circumference of the Earth. And his answer was actually 95% accurate of what we know of the Earth's size today. So by finding the angles, and he found that the angles differed by 7 degrees, or around 1/50th of a complete circle, he concluded that the circumference of the Earth must be 50 times the distance between these 2 cities. And so these cities were 500 stadia apart. A stadia is like 2 miles-ish. And he gave him a measurement of around 250,000 stadia, which is incredibly accurate. Many historians believe that the stadia was 157.6 meters, and this would make his calculation to come out around 39,400 kilometers, which is incredibly close to modern circumference measures of 40,075 kilometers. So probably the greatest of the early Greek astronomers was Hipparchus, and he was best known for his star catalog. And he determined the location of almost 850 stars, which he divided into 6 groups according to their brightness. He measured the length of the year to within minutes of the modern year and developed a method for predicting the times of lunar eclipses to within a few hours. And so at that time, a lot of Greeks believed in what is called the geocentric Earth theory, and they thought that the Earth was a sphere that stayed motionless at the center of the universe and everything else orbited around it. In the geocentric model, the Moon, Sun, and the known planets Mercury, Venus, Mars, and Jupiter orbit around the Earth. But they also thought that beyond the planets was a transparent, hollow sphere on which the stars traveled daily around the Earth, and this was called the celestial sphere. To the Greeks, all the heavenly bodies except 7 appear to remain in the same relative position to one another. These 7 wanderers included the Sun, the Moon, Mercury, Venus, Mars, Jupiter, and Saturn. And each was thought to have a completely circular orbit around the Earth. The Greeks were able to explain the apparent movements of all celestial bodies in space using this model. This model, however, was clearly not correct. The heliocentric model was developed by Aristarchus, and he was the first Greek to believe in a heliocentric model. And in the heliocentric model, Earth is just another planet that orbits around the Sun. Aristarchus used geometry to calculate the relative distances from Earth to the Sun and from Earth to the Moon, but he came up with measurements that were much too small, and that's one of the big reasons why no one believed him. However, he did learn that the Sun was many times more distant than the Moon and many times larger than Earth. Though there was evidence to support the heliocentric model, the Earth-centered view dominated Western society for nearly 2,000 years. Much of our knowledge of Greek astronomy comes from Claudius Ptolemy, and in a 13-volume work published in 141 AD, Ptolemy presented a model of the universe that was called the Ptolemaic system. It accounted for the movements of the planets as well as retrograde motion of the planets. Just like the Greeks, Ptolemy's model had the planets move in a circular orbit around a motionless Earth. However, the motion of the planets against the background of the stars seemed odd. Each planet, if watched night after night, moved slightly eastward among the stars. Periodically, each planet would also appear to stop and reverse direction for a time, and then resume in an eastward motion. This apparent westward drift is